Okay, if I have x equals 3, what's 1 over x? Not too much. 1/3, good, which is 0.33. 1/3, so that's going to be 3 comma 0.33. Good. If I have x equals 2, what's 1 over 2? 0.5. When I have x equals 1, what's 1 over 1? Good. Okay, here's where the action starts to pick up a little bit. When x equals 0.5, what is 1 over 0.5? 2, okay? Let's do better than that, bro. 0.5, so 0.5, good. When x equals 0.1, what is 1 divided by 0.1, please? 10, okay? That's sort of weird. Okay, when x equals 0.01, what is y equal? 100. Cool. Okay, and when x equals 0, what does 1 over x equal? It equals error. Okay, if you're still working on your table, can you guys just look up for a sec? Okay, before you finish your table, we'll get to the other side in a sec. I wanted to get a little point about these values here. Let's say x were to equal 10. What would happen to the y value? 1/10, smaller. Let's say x were to equal 100. What would the y value be? 0.01, 1 over 100. Is it ever possible to get to 0? No, right? Because again, if I'm ripping up the paper dividing by 2, you're never actually going to get to 0. Okay? Same thing going the other way. If I were to say x is 0.001, y is going to be like 10,000. If x is 0.000000001, y would be like 10 billion. All right. So the thing is, you can't actually get to 0, but you can get very, very close. All right. So we have to have a logic for that. As you're getting very big in your x's, your y's are getting very, very close to 0. They're not hitting 0. And the same thing for your x's. X's is getting close to 0, but not hitting 0. Your y's are getting enormous. Okay. Let's graph that, and then we'll come back to the negative side in a sec. Okay. So what that's going to look like on my graph is this. When x is 1, y is 1. When x is 2, y is 0.5. When x is 3, y is 1/3. When x is 4, y is 1/4. When x is 0.5, y is 2. When x is 0.1, y is 10. This graph should look familiar to you. Okay? That's what this graph looks like, which is 1 over x. We'll deal with the main range in a minute, okay? Because that's going to be where the action comes in there. Okay? And you guys should look familiar to you guys, right? That graph, I hope. Right? You've seen that before. Now again, the logic I want to get out of here. As this gets bigger and bigger and bigger, you're going to keep on getting closer to 0, but not quite hit 0. Okay? The same thing over here. As I get closer and closer and closer to 0, this number's going to get bigger and bigger and bigger. All right, let's do the negatives. Negatives will be the same thing but backwards. 1 over negative 0.1 should be negative 100. So that should be negative 0.01 and negative 100. Negative 0.1 should be negative 10. So that should be negative 0.1 and negative 10. Negative 0.5 should be negative 2. Negative 1 should be negative 1. Negative 2 should be negative 0.5. I hope you guys have all these worked out. That's the dream anyway. Okay, so for the left-hand side, the things work out to be the very same as this. Things work out to be the very same as this, put in the negative quadrant there, okay? So as you're heading further to the left here, you're going to again come close to 0 but not quite hit it. as you're coming close to 0 here, it's going down to negative infinity. I'll do this side in blue. So negative 1 is negative 1. Negative 0.5 is going to be negative 2. What else? Negative 1/10 is going to be negative 10, which is going to be down here someplace. Negative 2 is going to be 0.5. Negative 3 is going to be 0.33, and so on like this. And there's your graph of 1 over x. Okay, let's talk about domain and range, and then we'll talk about how to do this in general. Because doing a table of values for a graph is a pain, as you're probably aware. We're going to deal with transformations and all that stuff, like what we did for, like for any sort of function, we can do that. This is still a function, okay, right? There's only one y value for each x for this. What's my domain for this graph? Someone go ahead. Good. So my domain is going to be x/x cannot equal 0. What is the range for this graph, please? Hello. Someone else in summer. Some of your excellent domain and range. Someone else here, please. Yeah, go ahead. Y cannot equal 0, the same thing. We're going to say lines that the graph comes close to. But doesn't touch are called asymptotes. And here's the joke section of today's class. And actually, I've been waiting, Quinn, for quite a long time for you to be in my class. No pressure. Okay? Because when I told your brother about this, he swore to me that he went home and he called you an asymptote and he got grounded. That. So does that actually happen, or does that not happen?
I don't know. I like to block out everything that he said.
Okay, well, he swore to me that happened. So, and because this joke has been going for 5 years, so please don't call your little brothers and sisters asymptotes. You will get in trouble. Okay? Well, so I really thought it happened. Now I'm doubting myself here. Okay. So for reciprocal graphs. Asymptotes will be y cannot equal 0, and the restrictions on x. So if you remember, all the way through this unit, we dealt with x cannot equal. What that's going to look like on the graph is a dotted line equals like this. Okay. So we'll deal with that in a few minutes here. Okay. So that'll also show up in your domain and your range. Yes.
Why is it 2? Because technically, if like x was like 1, then you wouldn't have the graph. You just have like a 1.
Yeah, we'll deal with that. If x cannot equal 1, yeah, we'll do it.
Let's just say you only have positive values. You wouldn't have so you wouldn't have like y couldn't be a negative number.
Right. Yeah. If we were to change our domain, though, right? So the 1 over x is both these together, like that, even the 2 colors, but it's the entire thing there. Yes. You guys are so accurate. It's wonderful. I get too excited. I was ready to tell that joke, so I was like setting myself up for it on the inside. So there should be a line. Thank you. All right, let's get to a real example, okay, for what this will actually be. So, example 2 is going to say graph f of x is equal to 3 all over x squared minus x minus 6 in state, domain, and range. Okay, this is a question that could very well be on your next test, and your next assignment, and your midterm, and your final exam. Okay. All right, when you look at that question, what's the first thing you always want to do instantly? Summer. Factor instantly. So how does x squared minus x minus 6, how does that factor? Summer, go. Good. So I'm going to change this right away to f of x is equal to 3 all over x minus 3 and x plus 2. Wonderful. Okay, so we factored right away. What are my asymptotes going to be here now? What can x not equal? Go ahead. Okay. So we're going to say my asymptotes, so just make a little list here. X cannot equal 3. X cannot equal negative 2. We are actually still missing one asymptote. Sorry? Which one can't be 0? Oh, sorry, we can't talk. I'll read your mind though. What she said was y cannot equal 0. Okay. This is an always. Until you get to grade 12. Okay. The reason for that is it's impossible, if there's a 3 in the numerator, it's impossible to have a 3 change to a 0. Right? If there were a variable be in the numerator, then you could deal with that, but for right now it's impossible. Are we okay in our asymptotes where those 3 things came from? Please be brave and ask if you're not, okay, because this is tremendously important. Okay, I'm going to sketch this now before I deal with anything else. Okay, so I'm going to sketch my asymptotes before I deal with anything else. So, okay, so what you should be doing right now is getting out your graph paper, your handy dandy graph paper. I'm going to borrow. What I would recommend doing if I were you, and I'm not you, but I'm not going to fold the paper, I don't want to do this. But what you should be doing is maybe thinking of folding it into fours if you can. If you have a graph paper in a booklet form and you can't, that's okay. But probably this would be enough room too. If you want to do half a page, but generally you should be able to get 2 or 4 graphs on each side of this. Okay, so here we go. So I'm going to do a little sketch here and we'll deal with the details in a sec. All right? Sorry, done? Did you finish that? Sorry. Amanda? Okay, so what I'm going to do is I'm going to draw my graph here. There's my beautiful axes. But then I'll put arrows on here. I'm going to draw 1, 2, 3, 4, -1, -2, -3, 2, 3, 4. Okay, there's the graph. Okay, so there's my nice graph. All right, now, Jennifer, I'm picking on you today. Even though you've never seen this graph before, do you remember how we drew asymptotes? What do we do for asymptotes? Okay, too much pressure. Riley, remember how we draw asymptotes? Oh my goodness. Liam, how do we draw asymptotes? You mean the dotted line. Dotted lines, thank you. Okay. So what I'm going to do here is I'm going to draw a little dotted line across like this. And this is going to say y cannot equal 0. I'm going to label that in there. Okay, so that's like a magic line that the graph's not going to cross. What I'm going to do as well is I'm going to put -2. I'm going to draw another line just like this. If I had a ruler, this would be even better. So that's going to be x cannot equal -2. Over here, I'm going to draw another line. I'm going to say x cannot equal 3. Okay, please be brave and ask if you don't know where those are coming from. Okay, what I'm doing here is I'm taking these asymptotes here. So these are my roots, like what I can't equal for the restrictions. I'm putting one here and one there. Those are the two vertical ones. The horizontal one in grade 11 will always be y cannot equal 0. Now we have to figure out what happens to the rest of the graph. Okay, so we're doing the outline of the graph. We'll do the inside of the graph in a sec. Please be brave and ask. Tristan, you good? Yep. If feel bad to try and run 3 kilometers per hour faster than it. Sorry about that.
You were a basketball star back in high school, so